let's hope it will work. Okay, so last time we didn't finish this slideshow about arrays and lists. And yeah, I think this is where I stopped approximately. Just a minute. So I mentioned that if you use arrays, you typically need to use loops. Just if you check out this, this source code here, I just want to fill the array with elements from the console, right? By the way, if there is something wrong with the stream, please let me know.
Okay.
Okay, and there are typical problems which you have to solve in exercises in your test, for example, in your exercise class. I think last time I explained those. Did I? Okay, you probably don't remember. So let's just see. You typically need to display the array elements on the console, right? Or fill the array, as I already mentioned. Or I don't know. Have you ever filled an array with random numbers?
Yep.
Yeah.
Yeah.
Okay, great.
It will last.
Exercise class.
Yeah, exercise class.
Okay, okay. So today I'm also going to talk about the background of generating random numbers. So this is cool. Or typically you have to search for an element in the array. For example, you are looking for positive elements or even elements, or you are looking for strings which whose length is greater than a given value or something like that. Sometimes you don't only need to search for elements but to count them, or this is also very typical to calculate the sum or product or the average of elements, or looking for the maximum and minimum elements. I think this is not correct in English. Okay, so these are very basic algorithms with a typical implementation, and if you know this typical implementation, this can come handy, for example, in your test. So let's look at some of those typical implementations. So this is about filling the array with elements, but also to check if the element fulfills a given criterion. For example, here, as if you check this out, I would like to ask the user to enter elements which are between 1 and 100. If the value is not in this range, then I just skip this part here. So I'm not going to store that element in the array. I just skip this part and rerun the loop again. So, for example, if your exercise class teacher tells you to ask the user to enter usernames and store the usernames in an array, but the username should be at least 3 characters long, then of course you have to do something similar to use an if inside to check if the given username is not shorter than 3 characters, and if it is, then you just use this continue here. Okay. Okay, so I think this is something you already know, how to calculate the sum of the elements in the array. Have you ever used this before?
Maybe.
Yeah.
But maybe, but not in C#.
Not in C#. Yeah, this is. I mean, These are basic algorithms which work the same in any other programming languages, of course with different syntax. You are going to have a course about basic algorithm and data structures, and there you will this will precisely be the topic you will learn about what are the basic algorithms. This is only C# implementation. Okay, so how to calculate the sum of the elements in an array? Of course, you need a for loop which takes all the elements, and of course you need a variable which you always increment by the current element of the array. This is important here. You have to initialize the variable to 0, right? Okay, so you can implement the same by using a for each loop as well. Have you ever used a for each loop before?
No.
No. Okay, so we learned about 3 types of loops in C#: the for loop, the while loop, and which was the third one? For loop, while loop, and
Do while.
the do while loop. Exactly. And there is a fourth type kind of loop, the for each loop. So here I'm using this one, and I'm going to explain this in the subsequent slide. So with a for each loop, you can calculate the same. You can do the same. Basically, if you check this out, the for each loop takes all the elements in this array. So this is the syntax. We take the array and all the elements in the array. The loop variable is of the same type as the type of the array elements. So x basically, this variable x basically represents the current element of the array. And here we add this element to the variable sum. So yeah, the for each loop just traverses through the array and uses a loop variable which takes always the current element of the array. Okay, so this is how it works. The for each loop just copies all the elements one by one into this variable, and that's it. So it's so simple, so easy to use. Starting with the zeroth element until reaching the end of the array, and that's it. So this is what I use here, and it's I guess you agree that it's much nicer than the for loop implementation. For example, here I don't need to know what is the index of that element. I just need to know the value of x, right? So it's not really necessary to use indexing. I guess you understand that. If you don't, please ask anything about this. Yeah.
In the case array is squared or cubic or more.
Could you repeat it?
Let me. Oh, we can have this type of array. I wrote in chat.
Yeah.
What in this case?
Yeah, this is a two-dimensional array.
Yeah.
I'm going to talk about them soon. Okay. Here.
Okay.
So you already used two-dimensional arrays in what language?
Pascal.
Pascal. Okay.
Yeah.
Okay. C# has the same concept of multidimensional arrays with different syntax. So we will see how it works. A for each loop works also over multidimensional arrays. I will show it to you soon how it works.
Okay.
It works the same basically. Okay, but okay, a for each loop is very convenient to use, but there is a limitation here, and this is it. This loop variable x stores only a copy of the array element. Therefore, if you look at this this example, you can only read from the array inside the for each loop. You cannot override an element in a for each loop. Just copy this code and try it. You will get an compile time error here, compile error here. The C# compiler doesn't allow you to assign a value to this loop variable. So if you want to fill the array with elements, you definitely need to use, for example, a for loop. There, assigning a value to an array element is allowed. So this is the only limitation of the for each loop in this sense. Okay, let me talk about two more basic algorithms, and then we are going to talk about the topic what Oleg suggested. So, for example, calculating the average. This is also a typical problem. For instance, just imagine that you are implementing a web shop and you want to calculate the average prices of products. Or let's suppose after getting your degree, you are going to work at Google in the YouTube team, and yeah, your task will be to calculate the average how is it called, the average time of users watching a video, for example. Okay, so what calculating the average is very simple. You can start with calculating the sum, as I showed you before, and after that, what do you have to do? You just need to divide the sum by the number of elements, and that's it. However, be cautious, because if you do it in a simple by using a simple division and you are working with integers, here something will happen. Something happens, as I'm writing here. The result will be truncated to an integer. So of course the average can be a floating point number. If you use integers and you have two integers in this division, then the result will be an integer. It will be truncated. I have been talking about this rule in the .NET framework. So just keep in mind, you definitely need to have at least one of the operands to be float or double. Okay.
But shouldn't I store the value first at a variable with double, not just to make the whole equation double at once?
You mean here you should use not an integer, or what? Or,
Yeah,
or
no.
here?
At the last line, double sum divided by a dot length. Shouldn't I store the value first at a variable, because this way sum is the only variable that is double?
Okay, I think I understand what you mean. Okay, let's give it a try. Okay.
Okay.
Here I open this online C# compiler. I didn't want to open Visual Studio because it kills my computer. Okay, and let's suppose we have five numbers, like 10 and I don't know, 3, and so on. I try to use ugly numbers like I don't know, 8. Okay, so we calculate the sum of those numbers in the array.
The index number for the last two.
Yeah, thanks. Okay, great. And what do you want to do exactly?
The print, yeah, double.
Yeah. Okay, so you want to use a variable,
Average,
and
yeah.
in this variable you want to store the average,
yeah.
something like that.
Yeah.
Okay, and then let's just write the result in on the console. Okay, let's see. It's 7. Okay, maybe it's really 7, but I'm not sure. So the sum of yeah, let's write the sum as well. Display the sum as well. It's 39 divided by 5, so it should be 7 dot something. So it's truncated. This is the point. Why? Because here you have an integer variable sum divided by an integer. So in this case, the type of this expression on the right hand side is integer. This is truncated. The right hand side is truncated, and only after that you store the truncated value inside the double variable. Do you understand that?
Yeah, can I make n the sum equal 0.0?
Here?
Yeah.
Yeah, but for this you need to change the type.
Okay.
Okay, this will work. Oh, no. So this works.
Yeah.
However, it's a little bit, how to say, this is too much, because you can be sure that the sum will always be an integer number, right? You are summing integers, so the sum will be always an integer. Okay, this solves the problem, but this is not very nice. It's nicer if you convert at least one of the operands here to double. This is what I'm trying to say. So you learned about this time conversion or casting. You can either cast the first operand to double or the second one. It doesn't matter. And this also solves the problem. Okay. Thanks for your question. I'm suggesting you to keep always the minimum types. Here, the minimum type is integer, because the sum will always be an integer value, and you should convert something to a floating point number only when you really need it, and this is the exact spot where you need it. This is my message. Okay, guys, let's see another basic algorithm here. We are searching for the minimum element, for example.
Where is this there?
Okay, so this is a typical implementation. Again, you should traverse along the list from the beginning to the end, so therefore I'm using a for each loop, and in each iteration I'm checking if the current element is less than the minimum element so far. So you definitely need a variable to store the minimum element so far. If the current element is less than this minimum, then, well, from now on, the minimum element will be x. Do you understand that?
Yeah. Well, I do.
Okay, so let's try this as well. Okay, let's suppose here I'm going to display the minimum number in this array. Let's see if it works. Okay, there is no IntelliSense here, so I have to type everything by myself. You know what? Let's decorate this text nicely. What? I don't know what happened. Okay, so let's see. So the minimum element should be 3. Does it work? Yes, it works. What if you want to use the maximum element here? What do you think? What should I change?
We should change if x is better than
Yes.
x.
Then
Then x equals to x.
Yes, exactly. Okay. So let's see if it works. Oh. Okay. Interesting. What did I forget to change? I got a very, very huge number here. So any idea?
Change max value.
Exactly. So
yeah.
this is really important. What is the initial value for this variable? When I was looking for the minimum element, it's really typical to choose the greatest possible element, greatest possible integer.
But we can solve it using the first element of the A array.
This also works. Okay, let's just check out. So one possibility is this one. Let's try this.
Yeah.
If it works. And your suggestion, there is another solution, and this is also cool.
A1.
To take always the first, I mean zeros element.
Yeah.
And this works as well. Right. And actually this works also for, also in the case when we are looking for the minimum element.
Yeah, so we don't have to change the max value, the mean value. We can.
Yeah, that's it. That's it. Okay, this is also nice. There could be only one catch here. When this throws an error if your array is empty.
Oh, yeah.
But in this case, it's not. So it should work. If it is empty, then there is no zeros element, of course.
Yeah, but if we are searching for the minimum or maximum element, so we know it's not empty.
Yeah. That's it. Okay, thanks for the hints. Can I continue with my slides, or is there any question regarding those slides? Okay, then let's talk about Oleg's favorite.
Yeah.
Multidimensional arrays. I mean, you have been asking about two-dimensional arrays. Yeah. So far we learned only about one-dimensional arrays. You have an array with elements in a row. This is one-dimensional, but sometimes you need two-dimensional stuff. For example, in Excel, in spreadsheets, you have tables with rows and columns. These are two-dimensionals. Yeah, in C# you can use two-dimensional arrays. Only the syntax differs from Pascal, for example. This is how you can declare a two-dimensional array, and this is how you have to specify the sizes in both dimensions. Size 1 represents the number of rows, and size 2 represents the number of columns, basically. So let's give this a try. Okay, here. No, okay. So now I would like to use a two-dimensional array, for example, with 2 rows and 3 columns. This is it. And then I would like to start to fill the array by using indexing. So what do you think? How can I specify the index of the very first element of this array?
0, 0.
0, 0, yeah. So both each element has two indexes, right? A row index and a column index. So I'm just pushing a value to the element in the z and in the row 0 and the column 0, like I don't know, 5. And this is how I proceed in the zeros row in row 0 and column 1. Let's just set this element to -1, for example. How should I continue with this row? Is this okay, or should I continue with filling the zeroth row?
No.
No.
We should stop on the element 2.
Exactly. So the rule is the same. If we have 3 elements in each row, then we should count them starting from 0 until we reach 2. Exactly. So now we have to skip to the next row, the first row, and continue with filling the array, like and this is where we have to stop. Of course, we can have only 6 elements in this array, and that's it. Okay, I made a mistake though. I don't know if you can discover it, but also I get a very mysterious error message here, which says something like that. This looks like a nice face with a very long nose, or even, oh no, looks like a completely different object anyway. Yeah, so in C#, even when declaring a variable, you have to show that this is a two-dimensional array. It will have 2 indexes. So don't forget about this. In C#, you can even have 3-dimensional, 4-dimensional, any dimensional arrays. The idea is the same. Don't forget to put commas here. So for example, if you are about to declare an n-dimensional array, how many commas do you need to use here?
n-1.
n-1, that's it. Good, nice. Okay guys, so let me show. Actually everything works very similar. You were asking about, I think, the for each loop, how it works with a 2-dimensional array. So let's see if I can iterate through a 2-dimensional array in the similar way I did it with 1-dimensional ones. And yeah, it will work the same. Yeah, but how to say, now it doesn't look like a 2-dimensional array. A 2-dimensional array should be represented or visualized as a table with rows and columns. So the question is, how can I visualize this 2-dimensional array in rows and columns? What do you think? We should not use the for each loop. We should use something else.
First, we will
We
sign
can
a
use
variable for the rows, and then we sign variable for arrows. Column, I mean columns. Yeah, rows and column X and Y.
And what kind of loop should we use?
For.
We should use 2 for loops.
That's it, 2 for loops. 1 for rows, 1 for columns. And as you suggested, this is typical to use I for row indexes. So now we have, okay, so I less than a.length, right? So this is the typical implementation, such a loop, and we need another loop inside the first loop, which uses, for example, j for column indexes, right? And now let's write, okay, so I less than a.length, right? So this is the typical implementation, such a loop, and we need another loop inside the first loop, which uses, for example, j for column indexes, right? And now let's write, okay, so I less than a.length, right? So this is the typical implementation, such a loop, and we need another loop inside the first loop, which uses, for example, j for column indexes, right? And now let's the array elements to the console. How to do that? How can I index?
I point J.
Not point, comma, but you are right.
Comma,
Yeah, comma.
comma.
Yeah, that's it.
Then like we can add some fancy things like \T to make space between them. Like yeah.
Really good. So I think you suggest not to break a line after
Yeah.
the element, but to put a tab after that.
Yeah.
Something like that.
Yes.
Okay.
Yes.
And after each row, it would be nice to break a line. So it will look like a table, a spreadsheet, something like this. Is this okay? Similar
Yeah.
to what you suggested?
Yes. Yes.
Okay, so what do you think? Will it work or it won't work?
50-50. Yeah, I'm not sure until the program runs first.
I mean, these lines are cool. There is no flow in those rows. There is a flow in the other two rows here, and we get a runtime error. The index is outside of the bounds of the array. This is what it says. Actually, the first three elements were displayed nicely, but after the third element, the program crashed. And this is because if I display, or if you have any idea, please go ahead. So if I display the lengths of the array, what do you think? What number we will see? What is the length of the array now?
Now it's
3.
2.
No, neither. Not 2, not
Neither.
3.
Seriously? No.
It's 6.
Okay, 4.
6. So the a dot length gives the overall length, the number of all the elements in the array. Therefore, we try to run this row index and this column index until we reach 6. But we don't have so many rows and columns. Okay, long story short, please meet this guy here. This is how you can query the number of rows and number of columns. There is a getLength function inside an array which takes a parameter. This parameter is the index of the dimension. So the dimension of rows has the index 0, the dimension of columns has the index 1, and so on. So this is what we have to use here instead of the overall number of elements. Okay, let's give it a try. Okay, nice. Now it works. Now it looks like a table, right? Actually, it was a really cool idea to use tabs because now all the elements are aligned vertically. Okay, any question or remark here, maybe?
What is 0 and 1 are used for in the GitLint?
0 is, so we have to, here, just a minute, here the parameter gives the dimension, I mean, in which dimension I would like to get the length, in the dimension of rows or in the dimension of columns, in the first dimension, in the second dimension, the third dimension, that's it.
Yeah, okay.
So basically this is the index of the dimension. If you have a 4-dimensional array, you should use here 0, 1, 2, 3.
Yeah, okay. Thanks.
Of course, for a four-dimensional array, you need to use for loops here, not two. Just imagine that. Actually, later in other subjects, you will have subjects like computer graphics or game development in 3D, something like that, and there you will definitely use 3D arrays and also 4D arrays. You will learn in computer graphics that in 3D graphics you definitely need to use 4-dimensional arrays. This must be surprising, but this is a fact. This comes from the mathematics behind 3D graphics. You will see that. Okay, here in high-level programming languages, we don't use such
in vectors, right?
In vectors.
Vectors, yeah. In when shot is hit and something like that.
Yeah.
In physics. Oh.
Yeah, exactly. Also in the physics of games, also in the graphics of games. For example, if you want to rotate an object, it's better to use it's typical to use a 4-dimensional array. No, maybe no, maybe this is not the case. I don't know. I'm not sure, but you definitely will need 3-dimensional arrays. I think Mr. Troll will give you this kind of lectures. Okay, let's continue. Yeah, this is it. So very shortly, it's really annoying sometimes that you have to, at initialization, you have to initialize the different array elements in different instructions. So there is a shortcut. You can use this bracketed initialization with one-dimensional arrays and also with two-dimensional arrays and multi-dimensional arrays. Here you can see how it works with a one-dimensional array. Just enumerate all those elements on the right-hand sides here with two brackets, and that's it. You don't even need to specify the size here because yeah, the C# compiler can look at the number of elements here, and it can of course conclude what is the length of the array. Okay, so this works very similar to multi-dimensional arrays, but you have to be cautious because you have to use extra brackets around dimensions. So let me show you how this works here. Instead of using those separate lines, can I comment them out? Maybe I cannot. I could just enumerate them here, separated by commas, right? But meanwhile, I forgot something. What did I forget? So you don't know what did I forget here?
No.
Okay. So this works for one-dimensional arrays, but two-dimensional arrays you have to use extra brackets around dimensions. So now I have two rows. Each of them consists of 3 elements. So this is the first row here, and then this is the second row. That's it. Okay, but it's basically the same. So it's much better, right, than to use separate lines for each array element. Yeah, and you can also save this space here. No, it doesn't work because I erase too much here. You have to keep the comma, but you can eliminate the sizes. Okay, any question? Nope. Okay, then let's switch to lists. So this was all I wanted to share with you about arrays. Now I would like to talk about lists. This slide is about lists as well. Have you used lists in your exercise class already?
No.
Okay, thanks. But you will. Soon you will. Last time I told you that arrays and lists are really similar. Actually, those are the common properties of arrays and lists. The only difference is about the sizes. An array has a static size, while a list has a dynamic size. So typically you start with a empty list, and then you add a new element to the list and a new one. Then you decide to remove one of the elements. Then you can decide to add several elements to the list again, removing elements. So the list can grow and shrink on demand. So how can we use a list instead of an array? Because frankly to say, using lists is much common than using arrays in real life. Last time I think I explained this to you. So using lists in C#, this is how it looks. This is the syntax basically. It's completely different than the syntax of using arrays. So first of all, this is the type you should use in the declaration of this variable. So it starts with the name of the type. Actually, this is a type in the .NET framework. More precisely, this is a class, a built-in class in the .NET framework. You already learned about other classes. For example, console is a class, or string is a class. There are so many classes.
Square root?
No, square root is a function, but math dot square root, this is how you use it. Math is a class. Have you ever generated random numbers in your exercise class?
Yeah.
Yes. Random is also a class. So classes are, how to say, non-basic types in the .NET framework. In next semester, soon I will tell you more about classes, and in the next semester, in high-level programming languages 2, we will learn only about classes all along the semester. Anyway, just use this class here and use those funny brackets. I don't know how they are called. Angled brackets to enclose the type of the elements. So this is a list of integers. This is a list of strings. We learned last time that a list is a homogeneous type, so it can store elements of the same type. This is how you have to specify the type in advance. Okay, so let's do this. Now I would like to use a list instead of an array, a one-dimensional list, because list can only be one-dimensional. This is also a difference compared to arrays. Okay, so what to write here? Well, here you have to repeat the type of the list again, and then to use two parentheses. This is the syntax you have to fixate in your brain. Now I'm not explaining why this is the exact syntax. In next semester, in high-level programming languages 2, we will learn why we use parentheses here, why we use those funny brackets there. You will see. Now just use this syntax. Okay, so next question. How can I put an element in the list? Can I use indexing? For example, can I put 11 in the list? Let's see. No, we get an out of range error. Why is that? What do you think? How many elements this list has in the beginning? I didn't specify a size for the list, so the list is probably empty at the beginning. It has no elements. Just look at this line. I'm not specifying a size. It's empty. So there is no zeros element. I have to use something here which adds a new element to the array. So this can be done by using this syntax here. This is how you can add a new element to a list. Sorry, to a list. And you can keep going. Let's add further elements. And then, well, let's just try to use a for each loop over a list. If it works, actually it will. Let's see. Okay, here they are. The elements there. The elements are there. So this is about how you can start with a list. Of course, we could use a for loop as well in a similar way we use it over an array. And I didn't mention, but I showed you can also use indexing over array over lists. So this looks the same for lists and arrays. The only difference is this part, right? So let's see if it works. It doesn't work. It says that the length is not contained by the list type or list class. Yeah, so here is a difference. This is it. So for lists, you should use the count property instead of the length property. For arrays, you use length. For lists, you use count. Don't ask me why. This is how it works. But apart from this, everything is the same. So this is easy. Okay. So, what can you see? When you add a new element, it is appended to the list at the end of the list. This is how this add works. You can add a new element to the end of the list. So sometimes you need something else. Sometimes you want to put an element in the middle or at the beginning, or in general, you want to insert a new element at a given index. So let's try this as well. So for example, here I decide to insert a new element between 11 and 19. So how to do that? Insert takes two parameters, the index to which you want to insert the element, and the value is the second parameter. So if I would like now to insert a new element between 11 and 19, tell me what index should I use here?
1.
Yes, 1. And let's just insert, I don't know, 15 between, right?
Yeah.
Let's see if it works. Yes, it works. It works because 11, the index of 11 is 0, the index of 19 was 1, but I would like to shift it by 1 and put insert 15 before 19. Yeah, that's it. Okay, let's see how we can remove elements. Here I'm mentioning two methods of this list class. The last one is the easier one. Just use the remove method and specify the value you want to remove. So for example, you know what? Let me remove the elements after this for loop. So let's remove, let's see, the negative value here, and let me display the elements again on the screen. You know what? Let me just write something here. Ah, come on. After deletion. Okay, let's see. Okay, it works. So I removed minus 20, 21. But of course, you can remove any elements you want. So, yeah?
What if we have two elements with the same value?
Good question. So let me now remove, I don't know, 11 here. And let's suppose I have 11 twice in the array, which is allowed. And let's see, what do we get here? Okay, so as you can see, we had 11 twice, and what happened?
Oh, it deletes the first.
Yeah, it deletes the first occurrence, only the first occurrence of 11. I think there is a version of remove which removes all the occurrences. I think this is how it is called, remove all. Let's see if it works. No. Yeah, it's a little bit strange. I think this is how we should specify this mysterious condition. Okay, it works. So both values were deleted. Well, there are special methods which can be used with special parameters. This is a special parameter which we use, which we call lambda expression. It sounds awful. Next, if you want, you can look this up. It's a high-level concept in not only in C# but in other programming languages. For example, in Java, in Python, definitely. I think even JavaScript has something similar. And yeah, and we are going to learn about this in high-level programming languages too. Actually, at the very end of that course, because we should learn so much about classes and generics and delegates, so many new stuff we should learn to understand what lambda expressions are. But if you want, you can try to start to use them because they are quite easy to understand. Thanks for the question. Okay, let's try something else. So what if I try to remove something which is not in the list? Like I would like to remove 3. What do you think? What will happen here?
Nothing.
Nothing. Yeah. So, yeah, nothing. Of course, we could get an error here, but we don't. Okay, there is another removing method which is easy to use, remove at, which is about, as I write here, removing an element from at a given index. So, for example, if I want to remove the element at index 3, it should work. Did it work? I have no clue. Let me keep only this removing. Yeah, it works. You see, minus 21 was removed because it was located at index 3. Index 0, index 1, index 2, index 3. So this was removed. Okay. Actually, there are so many methods of a list. I just mentioned those, and the remove all method, which you can also find here. If you just hit the dot operator, Visual Studio will also pop up this list box with all the methods inside the list. We can find remove all as well. Here it is. It has a funny parameter with a funny type anyway. You can also remove a range in the list starting from an index yeah, so there are so many options here. You can also add a range, so several elements. You can add several elements in one hit. Or what else? You can calculate the average of elements. This is interesting. So there are high-level methods in the list class as well. Just try a few. console.writeline.a.average. Okay, let's see what we get. Where is it? Okay. So this is the average. Okay, now the average is 15. Is it? Yeah, it is. Yeah. Accidentally, the average is now an integer number. Okay, let me add a new element here, like 3. And still, the average is an integer number. Yeah, I guess because of the same problem. Now I have integers inside the list, therefore the average will be calculated as an integer, not as a floating point number. This produces the same error I was talking about before. Okay, but you can find other methods as well, like you can clear your list, you can search for an element. It has this contains method which takes a value and tells you if the element can be found in the list. Or you can retrieve the index of that item in the list. Okay, so if you want, you can just browse this list of methods for a list and also for an array, actually. Okay, guys, do you want to ask anything about lists?
What if we remove an element from the list inside the for loop? What happens?
Well, it depends. I mean, if you do it right, nothing will happen.
Oh, so it's possible, but
for example, here, if you remove an element after using an element, then this shouldn't be a problem. Like, let's remove, I don't know which element. The second one. Okay, let's see. So nothing happened. I mean, no problem happened.
Okay.
It can cause a problem if you remove an element first and then you try to display it. Okay, it didn't cause any problem either. Of course, if I, for example, if you remove the very first element, this will, what? Okay, this doesn't crash. Okay, so this doesn't cause any problem, but I don't see if it makes any sense to use remove here. But yeah, but
that's it.
If you do this inside the for each loop, it's another story. I'm really glad you asked about this question. So this is the same, this does the same as the for loop before, and if now I remove an element, sorry, I was confused. Anyway, if I remove x, for example, I remove, yeah, I wanted to use remove at in the previous loop. Anyway, if I remove whatever element in the array, then I get an error.
Because for each is only for analyzing.
Well, let's see the error message. The collection was modified. Enumeration operator may not execute. It just tries to say that the for each loop is about traversing a list from the beginning to the end. And meanwhile, and if meanwhile your list shrinks a bit, then the dimensions, the length of the list changes, and for each cannot tolerate that. So the list must be kept intact inside the for each loop. This is a limitation of the for each loop as well. With the for loop, there is no such a limitation, so let's try it again. Here I wanted to remove the very first element, but yeah, and this can cause a problem actually. Why is that? Yeah, this can cause a problem because in every iteration I remove the very first element of the list, and in the last iteration I remove the last element in the list, and then I try to display it. So basically I remove an element, and after I try to access it, and it doesn't it cannot be accessed anymore. If I do it in the other way around, it doesn't cause any problem. Or it does. Interesting. Why is that? I don't know. It's interesting. I don't get this now. I don't understand why this throws an error. It shouldn't, because we check the loop condition after each iterations, and if the list shrinks, then this should return false. Okay, do you have any idea why we get an error message here?
Shouldn't it just remove the first number and then continue?
What should I remove?
No. The code itself for the for loop.
Yes.
Shouldn't it just remove the number with the first index and then continue? Like, I don't know what the error is showing up.
Is the A count calculated every time or only once?
Yeah, it's calculated every time.
Oh.
It is. it is queried every time. Interesting. I don't understand that. Okay, let's try to display the count. Okay, just to see if it is decreasing every time. You see, it's decreasing. When we reach 3, what? So we have 3 elements in the list.
Oh. I know why. Because we don't change anything in the I variable. So we do 3 operations,
Mm.
and then I is 2.
Mm-hmm.
After that, it adds 1 more.
Mm-hmm.
So I is 3, but
Mm-hmm.
count is 3, yeah.
Yeah, exactly. So this causes the problem when
Okay.
I is 3 and also the count is 3. Then we over-index. But I don't understand why.
Because we inserted 15 in a new index, which was for 19.
Oh, because we are trying to operate with the A3 element, but we don't have the A3 element.
Ah, you mean here? Okay. Yeah. Okay. I see now. So this throws an error. Yeah, okay. Yeah, okay. Yeah. Lesson to learn always. Yeah, that there is no not the line, the number of the line is not given here where the error popped up. Yeah, it would have helped. Yeah. Okay. So this is, thank you. Okay, guys, we have 10 minutes left, so let me finish this slideshow. Okay, first of all, you can initialize lists in a nice in this convenient way. You remember we did the same for arrays. You can do the same for lists actually. So instead, for example, instead of adding 3 elements here, I can just enumerate them at the beginning like that. So this is equivalent to this solution. Of course, after that I can insert new elements and add new elements and remove elements. It doesn't matter, but this is the initial content of the list. It's more convenient, more easy to use. Okay, then let's see what's the situation in other languages in a very in a nutshell. Okay, so Java is very similar to C# by default. Therefore, arrays work completely the same. Lists are a different story because you can think of a list as an idea. The list is a list of elements, I mean a sequence of elements. But you can implement such a list in different ways. You can implement it as an array which can grow and shrink, or you can store the elements separately from each other and link them. This is also called a linked list. So anyway, you will have a subject where you will learn about basic data structures such as lists. There are different implementations of lists. And Java has such a... So Java knows this. I mean, Java let the programmer know about this. Therefore, in Java, list is not a class. You cannot use the list as you use it in C#. List is just an interface, not a class. In high-level programming languages, we will learn that interfaces are basically specifications only, not implementations. And this specification can have different implementations, different classes which implement this interface. So for example, in Java, the ArrayList class is a concrete implementation of the list interface, or the linked list class in Java is another concrete implementation. Anyway, if you look at the code, basically here, after the new keyword, you have to give the concrete implementation, the class name, for example, ArrayList. Apart from this, there are minor differences. For example, the add method starts with lowercase a, but the idea is the same. Okay, C, C++. Well, in both languages, arrays are basic data types. Okay, the syntax is a little bit different so in C and C++, this is how you declare an array with a size defined. So you have to put the size after the variable's name between brackets. You don't have to use this new keyword and stuff, but the idea is the same. However, in C, there are no lists. I mean, not as basic data structures. In C++, you can use an extension library which offers such a list data structure. Okay, it's called not a list but a vector. Actually, it's a vector, it's a sequence of elements. If you look at the code, it is used almost the same as you use list in C#. You have to use these funny brackets for the type of the elements. You don't have to use the new keyword here. So there are minor differences. For example, this is also a difference. Instead of the add method, you have to use the pushback method. But anyway, the idea is the same. Python is a different story. Just imagine that in Python there are no arrays. There are no arrays, I mean not as a basic data type. You can import certain packages which provide the array data type, but actually doesn't make too much sense because in Python, list is a base type. It's supported by the language itself. If you look at the code, it's so easy to understand. This is a list which you just initialize with 3 elements. So this is basically almost the same what I did in C# here. But if you compare the two syntaxes, well, this is much intuitive. This is how you can add a new element, or you can add several elements. So, you know, the main functionality of the list is the same. Only the syntax and the level of convenience is different. 2 minutes left. Well, in the last slides, I'm talking about how you can decide when you should use an array or a list. For instance, your teacher in your exercise class tells you that please generate 100 random numbers and do calculations with them. So what do you think? You should use an array or a list? If you are with me, still with me.
Array.
Array, exactly. Why?
Because the user will enter the numbers.
Yeah, and you know the size the number of elements in advance, 100. So this is the exact size of your array, right? You have this fixed number of elements all along the program. However, for example, your teacher tells you, for example, read numbers from the console until the user presses the escape key. Then you definitely should not use an array, because you cannot know in advance how many numbers the user will type, right? So it cannot be predicted. So it's a typical kind of use case when your teacher or the specification for your program specifies an end value, or even this is also possible. You are going to, I just mentioned, you might go to Google after fetching your degree. There you would read data from streams. Of course, you cannot tell you in advance how many pieces of data you will read from a stream. So there you will definitely need to use a list. Okay, here is an example how to read something until the user types an end value. You will check this out by yourself. This is the last slide. Let me talk about this. If you have to work with streams in C#, there is a very handy class called Stream Reader, and basically this is how you can read data from the stream until the stream ends. As you can see now, I'm using a list because, again, you cannot tell in advance how many integers you are going to read from the stream. Okay, later we are coming back to this stream reader class, because the same class should be used when you read data from a file, and this is something we definitely need to learn. Okay, run out of time. Do you have any final questions, remarks?
No.
Okay, then I wish you to enjoy your lunches. Okay, so see you next week, guys.
See you.
Bye-bye.
See you.